So far, we have been talking about degrees, and we're used to degrees. We've used degrees in everyday life, but what are degrees based on? If you think of 360 degrees for a circle, where does that come from? Is it based on some kind of mathematical function? Is it based on some kind of property about the circle? No, it's actually pretty arbitrary. There's no actual rhyme or reason why we chose 360 rather than some other kind of number. There are some things that are kind of convenient about it. For instance, it can be divided by a ton of different numbers. It can be divided by 2, 4, 6, 8, 3. All of these kind of numbers that allow us to divide up the circle into really, really convenient parts. However, there is a better way, and that is to use a radian. And I know that you've heard about radians before, however, do you know really what they are? They are the far superior way to measure an angle. Why is that, you may ask? Well, I want you to check out this video right over here. Please look at it. That way you could have a proper understanding before moving on, and I don't have to explain it that much. So check out that video and then come back here. So as you just saw in the video, it's just a radius that's laid on the edge of a circle, and then as you go around, how many radiuses can you lay on the edge of a circle? It turns out you can lay 2 pi of them, or 6.28 something or another. Now, radians are far superior to degrees. The reason being is that it is actually related back to the circle. It's a physical property of the circle that describes the amount of turn that you take. Why is that important? Well, when you use it in mathematical functions and things of the like, you want something actually related to a circle. You don't want some arbitrary number that we picked out of a hat. We want something that means something, and radians actually mean something. Now, the first thing that you might want to know is how to convert from a radian to a degree and a degree to a radian. Again, I implore you to check out this video if you still haven't done it, because they talk about that. You are amazing students. So here we have radians to degrees and degrees to radians. This first one, degrees to radians, you will see that all you have to do is take the degree and multiply it times this mess right here, and it will convert it to radians. If you do the same thing on reverse, you're going to take the radian measure here, multiply it by this pretty little function, and it will get rid of the radians and turn it into degrees. So let's go into example 1 and actually do this. So the first example that we're going to be doing will actually be to convert radians to degrees and degrees to radians. So let's do that with negative 30 degrees. First of all, I'm going to write down negative 30 degrees, and what am I going to multiply it by? Well, we could look back at our formulas right over here. I'm going to see that I'm going to multiply it by pi over 180. But how can I think of this? That way I don't have to refer back to my notes. How can I remember what to multiply it by? Well, I know that I'm going to multiply it by either pi over 180 or 180 over pi. Well, let's think about this for a second. What do I want to get rid of? This will be negative 30 degrees over 1. So I want to get rid of the degrees. I don't want it to be degrees anymore. So in that case, degree is going to be on the bottom, because I know that anything on the bottom of a fraction will cancel anything that's on top of the fraction if it's the same. So since a degree has to be on the bottom, I know that's going to be 180. And on the top, that only leaves one thing. That's going to be pi radians. I'm just going to put rad because math is cool. Alright, so the first thing I will do is I'm going to type this into my calculator, but I want to leave out the pi. The reason why I'm going to leave out the pi is because it's going to be there. It's not going to move. My answer, we wanted to have pi in the answer. So therefore, I'm going to leave that there and just ignore it. I'm just going to say negative 30 over 180, and let's see what happens. So I'm going to go to Desmos, negative 30 divided by 180, and there is a decimal. How do I get rid of the decimal? I don't want a decimal. I want a simplified fraction. How do I get that? Well, this button right over here allows us to toggle back and forth between decimals and simplified fractions. So I have my simplified fraction here. I'm going to go back to here, and as we saw, this will be -1/6 times pi. So all we have to do is just place that pi on the top. So this will equal -pi/6. And that is our radian measure, -pi/6. It's really not that difficult as long as you place the numbers in the right spot. So let's try it with this next one. And this will be 5pi/2. Of course, this will be radians. And I need to convert this into a degree. Again, what do I not want here? I don't want the radian. I want to turn it into degree. So to get rid of the radian, I'm going to put radians on the bottom. That is going to be my pi. Now on the top, I want to change it into degrees, so I will say 180 degrees, and now I'm going to perform the math. The easiest way to do this is to take the top, multiply across, and take the bottom and multiply across as well, and then see what is left over. I checked before, and 5 times 180 is 900, and the bottom is just going to be 2. Where did this pi go? This pi radians go? Well, if we notice, the pi radians canceled out. It is completely gone now. All we're left with is numbers. Now, I'm going to specifically say this is going to be 900 degrees, 900/2 degrees. So what does this equal? 900/2, that's pretty simple math. We don't even need decimals for this. This will be 450 degrees. So this is how you convert from degrees to radians or radians to degrees. Let's take a look at our guided practice. Now we want to convert 120 degrees into radians. And then we also want to convert -3pi/8, which is radians, and we want to turn it into degrees. So let's see how we can do this. And here's where I want you to pause the video just to see if you can actually do this by yourself. Good job for pausing the video. I knew you had it in you. And I know you got these answers right as well, because you are a fantastic student. But even if you didn't, that is fine. You are still fantastic. Let's do these questions here. 120 degrees. 120 degrees. How do we go from degrees to radians? I'm going to put this over 1. I'm going to multiply by pi radians, because that's what I want to turn it into, divided by 180 degrees, because that's what I want to cancel. Let's go ahead and do the 120 divided by 180 right away. 120 divided by 180, that equals, I have to press this button, 2/3. So I'm going to write down 2/3. Now remember, this pi is still there. What do I do with the pi? I just place it on top, and this is going to be my finalized answer, 2pi/3 radians. Let's try out for B. Here we have -3pi/8. How do I change this into degrees? I'm going to multiply by 180 degrees because I want to turn it into degrees, and divide it by pi radians. Now remember, this is going to be radians as well. But anytime you see the pi, you can just assume that it's going to be radians. Here, we know that the radians will cancel out. The pi and the radians will cancel out right away. So we just have to do -3 times 180, which will be -540. And we have to divide that by 8 because that was what was left over on the bottom. negative 135 over 2 degrees. When we're dealing with degrees, we will accept fractions. However, decimals are a little bit better, because if I say turn 135 over 2 degrees to the right, does that make sense to you? But if I say to you that this is going to be 67.5 degrees or negative 67.5 degrees, that makes a whole lot more sense. So let's use the decimals when it comes to degrees and fractions when it comes to radians. So here we have negative 3 pi over 8, and that will equal negative 67.5 degrees.